Good day, class. Okay, everyone, please stand up. Sheila, can I lead us to prayer? Amen. Good morning, class. Okay, please sit down. I will check your attendance first. Who are absent for today? None? Okay, very good. Do we have an assignment? None. But before anything else, let us know first our classroom nurse to have an organized session. Everyone, kindly read. Thank you. Class, we are now at fourth quarter and we are a step away to ending this school year. Are you all excited? Well, yes, of course, because summer is coming. Okay, last meeting we tackled about solving problems involving the triangle similarity and right triangles, right? Okay, do you have any clarifications or questions regarding that? None? Okay. But first, let us have a short review or short recap about it. I will be asking and you will answer my questions. Understand, class? Okay. For the first question, it is used to compare two or more quantities. Yes, Dexter? Very good. It is ratio. It is a theorem that two triangles are similar if the corresponding sides of two triangles are in proportion. Yes, Leonard. Very good. It is AA similarity theorem. What about two triangles are similar if two angles of one triangle are congruent to two angles or another triangle? Yes, Cherry? Very good. It is SSS similarity theorem. What about a theorem that if a segment bisects an angle of a triangle, then it divides the opposite side into segments proportional to other two sides? Yes, Justine? Very good. It is triangle angle bisector theorem. Well, who is this who believed as the first person to determine the difficult to obtain heights without the aid of measuring tool existed even before Christ from 624 to 547 BC? The Greek mathematician who determined the heights of pyramids in Egypt by the method called shadow reckoning. Yes, Thalia? Very good, it is Thales. Very good, you have mastered our last topic. Give yourselves a clap. Okay, Nan. Do you have questions or clarifications or further information to share with? None? Okay, let us now proceed to our discussion. Now, class, I have here a puzzle for you to solve. There are 11 words for you to locate or trace in the puzzle. I will give you 2 minutes. Is 2 minutes enough? Okay. I will give you 2 minutes to answer and trace for those words. You may now start answering. 30 seconds left. 10 seconds left. 5, 4, 3, 2, 1. Okay, time is up. Let us now check your answer. Okay. Well done, class. You easily found the words in the table. Give yourselves a big clap. Okay, so based on our activity, what do you think is our topic for today? Yes, we will we will tackle about 6 trigonometric ratios. But before that, everyone, please read our lesson objectives. Okay, thank you. Are you still interested to know about trigonometric ratios? Okay, you will know that by understanding the topic from our activity today. In this activity, you will be divided into two groups based on the color of your name tag. The red color will be the group 1 and the blue color will be the group 2. Each group must choose a leader, a secretary, a reporter, and it will be determined among your group. So, everyone, are you all in your respective groups? Okay. Here is your rubrics for your guidance. Can they read, everyone? Okay, thank you. So now, I will be giving you the activity. and you have to answer that within the span of 3 minutes. Is the instruction clear? Okay. I will give you 3 minutes and your timer starts now. 2 minutes left. 1 minute left. 30 seconds left. 10 seconds left. 5, 4, 3, 2, 1. Okay, class, time is up. Let us now check your activity. Group 1, who is your reporter? Very good, Group 1. Let us give them 3 claps. 1, 2, 3. For Group 2, who is your reporter? Very good, Group 2. Let us give Group 2 a 3 claps. 1, 2, 3. Very good, everyone. You are all doing a good job. Give yourselves a GOOD clap. GOOD, GOOD. Good, 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 good. Okay, you may now go back to your seats and please arrange your chairs. Are you all settled? Well then. So based on our activity, what did you feel about doing it? Yes, Ray John. Yes, you enjoyed the activity. What about you, Christian? Okay, the activity was exciting for you. So did you enjoy the activity, class? Okay, so for group 1, how did you come up with your activity, or how did you finish the task on time or before the time? Yes. I'm glad that you have followed the instructions given. So, what was the activity all about? Yes, it is all about 6 trigonometric ratios and parts of a triangle. So from the activity we had, what have you learned? Ara. Okay, so yes, we have 6 trigonometric ratios with respect to an angle. So what are these 6 trigonometric ratios? James. Yes, the 6 trigonometric ratios are sine, cosine, tangent, cotangent, secant, and cosecant. So when we say sine, what does it mean? Edmond. Okay, very good. Sine is a trigonometric function that is equal to the ratio of the side opposite a given angle to the hypotenuse. So what about cosine? Yes, Leonard. Very good. It is the ratio of adjacent to the hypotenuse. So what about tangent? Jessamy. Yes, it's the ratio of the opposite to the adjacent. So what about secant? Donaline? Yes, it is the ratio of hypotenuse to the adjacent. So what about cosecant? Yes, it is the hypotenuse to opposite. And what about cotangent? Yes, very good. It is the ratio of adjacent to the opposite. So, and what side is this that refers to the longest side of a right angle opposite the right angle? Carmela. Okay, very good. It is the hypotenuse. Very good, class. All your answers are correct. Give yourselves a GOOD clap. GOOD, GOOD. Good, 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 good. Okay. I guess you are all refreshed and you are all have somehow a grasp about our topic for today. Okay, please have yourself settled because we are now going to have a discussion. Okay, class, our topic for today is all about the 6 trigonometric ratios: the sine, cosine, tangent, cotangent, secant, and cosecant. In a right triangle, we can define actually six trigonometric ratios. Consider the right triangle ABC. In this triangle, we let theta represent the angle B. The leg denoted by A is the side adjacent to theta, and the leg denoted by B is the side opposite to theta. So the 6 trigonometric ratios we can define are the sine. Sine theta can be represented as B over C. So what is B over C? Yes, B over C, sine theta is equal to the opposite over hypotenuse. What about cosine? Cosine is A over C. So what is A over C? Yes, cosine theta is adjacent over hypotenuse. What about cotangent? Cotangent is A over B. What is A over B? Yes, it is adjacent over opposite. How about cosecant? Cosecant is C over B. So what is C over B? Yes, it is hypotenuse over opposite. What about secant? Secant is C over A. What is C over A? Yes, it is hypotenuse over adjacent. And lastly, the tangent. Tangent theta is the ratio of B to A. What is B to A? Yes, very good. It is opposite over adjacent. So, katoa is mnemonic used for remembering the equations. The ratios secant, cosecant, and cotangent are ratios reciprocals of the sine, cosine, and tangent. Applying the algebra shows the connection between these functions. Cosecant theta is hypotenuse over opposite. By following the algebraic concepts, we can actually convert it to 1 all over the opposite over hypotenuse, right? Because 1 divided by opposite over hypotenuse equals to hypotenuse over opposite, right? Yes. Yes, very good, because we are going to apply the rule of division, taking the reciprocal of the denominator, and we are going to proceed to the multiplication. We're going back. 1 divided by the opposite over hypotenuse. Opposite over hypotenuse is the ratio of sine. Yes, very good. So that is why cosecant theta, its reciprocal ratio is 1 over sine theta. Okay? Did you understand, class? Okay, let's proceed. The secant theta is hypotenuse over adjacent. Again, the 1 divided by adjacent over hypotenuse following the algebra concepts. Adjacent over hypotenuse, it is the ratio of, yes, cosine. So that is why secant theta is the reciprocal, its reciprocal ratio is 1 over cosine theta. And lastly, for the cotangent theta, cotangent is the ratio of adjacent to the opposite. Again, 1 divided by opposite over adjacent following the algebraic concepts. And opposite over adjacent is the ratio of tangent. Yes, very good. So that is why cotangent theta, its reciprocal ratio is 1 over tangent theta. Okay guys, did you understand? Okay. We are done with defining the 6 trigonometric ratios, and now we are going to discuss how are we going to illustrate the 6 trigonometric ratios. There are 4 ways on how are we going to illustrate this, and we are going to tackle this one by one. First is solving a right triangle given the length of the hypotenuse and the measure of one acute angle. If we are going to observe here in our figure, there is the measure of one acute angle is already given, which is 53 degrees at angle P. And also, the length of the hypotenuse is given, which is denoted by small letter t, and it is equals to 12. So what are we going to solve for? So we are going to solve for S and P, which is the adjacent side and the opposite side with respect to the angle P. Okay, how are we going to solve it? We are first going to figure what is the appropriate ratio we are going to use depending on the given in the problem. Since angle P is given and the hypotenuse is given, let us first find the adjacent side, which is the S. So adjacent side. So S is given, so which is adjacent. And our hypotenuse is already given. So therefore, A over hypotenuse. So what is A over hypotenuse? Or it is the adjacent over hypotenuse. So what ratio are we going to use? Yes, very good. It is a cosine ratio or the cosine function. Cosine theta is the ratio of adjacent to the hypotenuse. Our theta here is the P, which is equals to the cosine P is equals to adjacent. Our adjacent is S and our hypotenuse is T. So therefore our function is cosine P is equals to the S divided by T. With our angle P, it is already given that it is 53 degrees and our hypotenuse is 12. So therefore, we are going to substitute it to our function. Cosine 53 degrees is equals to S divided by 12. So what's next? Yes, we are going to cross multiply it. So therefore, after we have multiplied it, after we have cross multiplied it, it will now result to S is equals to 12 times cosine 53 degrees. So we have reached it, and what's next? Yes, we are now going to multiply the 12 to cosine 53 degrees, which is equals, or which is approximately equals to 7.22. Yes, nice question. Cosine 53 degrees is we can actually obtain this. We have a table for it, or if you have your scientific calculator, you can actually convert cosine 53 degrees to decimals, and you have to multiply it to 12. Okay, solving for the opposite side, it is already given in the problem. Our hypotenuse, our angle, and our angle. So since we are looking for the opposite side, so it should be, our function has to be opposite and hypotenuse, right? So in the 6 trigonometric ratios, what ratio is the opposite? What ratio has the opposite and the hypotenuse? Yes, it is sine and the cosecant. But of course, for conveniency, we are going to use the sine. So which is equals to the sine is equals to the opposite over hypotenuse. By substituting the given in the problem, sine P is equals to the P over T, where P is the opposite and T is the hypotenuse. So sine P is equals to 53 degrees and T is 12, is still basing on the figure. So sine 53 degrees is equals to the P over 12. So yes, we are going to cross multiply it next, and of course, we are going to multiply the 12 times sine 53, which is approximately 9.58. Do you have your calculators with you? A scientific calculator. Do you have? Okay, very good. The values of the trigonometric ratios for any particular angle are constant, regardless of the length of the sides. These values can also be found using a calculator. Also, you can use a calculator to find an angle when you are given a trigonometric ratios. First is finding a ratio given the angle. For example, to find the value of sine 38 degrees, ensure that your calculator is operating in degrees mode. For calculating, you just have to press the sign in your calculator, and you have to click on 38. Okay? Follow? Okay, very good. Sine 38 is equals to, yes, sine 38 is equals to 0.615661475. But of course, we are going to use two decimal places. Okay, gets? Does everyone follow? In finding a ratio given the angle, you just have to ensure the calculator is in the degrees mode, and after that you are going to press the sign or any function, and of course the given angle. And also, finding an angle given the ratio. In finding the size of the angle to the nearest minute, given the value of the trigonometric ratio, just follow the steps. Just follow the steps I am going to tell. So what is the value of the 0.725 when it comes to the ratio of sine? Right? So since nung una is hinanap natin ang exact value ng sine 38 degrees, which will equal to 0.616. What about if the exact measure is the exact value is given without nang hindi natin nalalaman kung ano ang kanyang angle, kung ano ang kanyang degrees. So that is why in your calculator, you just have to press the shift. It is in your upper left. It is in the upper left of your calculator. The shift, and you are going to press the sign. You follow? Yes, did you follow? Okay. The shift sign, and you have to press, you have to enter the 0.725. Okay, follow? Okay. Okay. Did you follow, everyone? Okay. Shift sign 0.725 is equals to 46.46884783 or 46.47. And actually, we can test that. And again, and applying the first way. So please enter in your calculator sine 46.47. Yes, right? It answers 0.725. So that's it. Did you understand, class? Okay, very good. So another way in illustrating the trigonometric ratios is solving a right triangle given one of the legs and the measure of one acute angle. So based here in our given or in the figure, one acute angle is given, and one side on one one leg is also given. So at angle B measures 67 degrees, and our opposite side measures 10.6. So we are going to solve for the other side, which is the adjacent and the hypotenuse. So first, let us first solve for the A. Angle B is an acute angle, B is the opposite side, and A is the side adjacent. Since in our given, the side given is the opposite side, and we are actually looking for the side of the adjacent. So opposite and adjacent, which trigonometric ratio contains an opposite and adjacent? Yes, it is tangent and cotangent. For conveniency, we are going to use the tangent function. Tangent function is opposite over adjacent. So tangent 67 degrees is equals to the B over A, where B is our opposite and A is our adjacent. Tangent 67 degrees is equals to 10.6 divided by A. So by using a cross multiplication, it would result to A times 1067 degrees is equals to 10.6. Since we are looking for the value of A, we are going to divide both sides by tangent 67 degrees. So A is equals to 10.6 divided by tangent 67 degrees. So again, 10 tangent 67 degrees. You can compute that on your calculator and we'll divide it to 10.6. So 10.6 divided by tangent 67 degrees is equals to 4.50. Who would like to solve for C or for the hypotenuse side? Yes, Aljamar. Thank you, Aljamar. Your answer is we are going to check it. Solving for C, angle B is an acute angle, C is the hypotenuse, and B is the opposite side of angle B. Since we are looking for the C or the hypotenuse and with the given of the opposite side, so opposite over opposite and hypotenuse. So with the 6 trigonometric ratios, there is only two ratio or there are two function containing opposite and hypotenuse, which is the sine and the cosecant. For the convenience C, we are going to use the sine. The sine of theta is equals to opposite over hypotenuse. Sine B is equals to B over C, which B is the opposite and C is the hypotenuse. Sine 67 degrees equals to the 10.6 divided by C. And then we are going to cross multiply it. Therefore, C is equals to sine C times 6 times sine 67 degrees equals to 10.6. And then we are going to divide it both sides by sine 67 degrees. Then cancel in the left side, which remains C is equals to 10.6 divided by sine 67 degrees. By dividing this, therefore, the value of C or the hypotenuse side is equals to the 11.52. Well, Aljamar, your answer is correct. Very good. The third illustration of the 6 trigonometric ratios is solving a right triangle given the measure of the two parts, the length of the hypotenuse and the length of one leg. Let's take the example. Triangle BCA is right-angled at C. If C is equals to 23 and B is equals to 17, find angle A, angle B, and the A. Express your answers up to 2 decimal places. First, we are going to draw or picture out what is it like based on the problem. So here, we are going to imagine or we are going to sketch the given in the problems. So it is said that triangle BCA is right angled at C. So therefore, our right angle is at C. If C is equals to 23, therefore our C is the hypotenuse since our right angle is at C. So our C is equals to 23 and B is equals to 17 is equals to 17. So therefore B is equals to 17 is the opposite of the angle B. So first we are going to solve for the angle A. Side B is adjacent side of angle A. C is the hypotenuse of the right triangle BCA. So the appropriate function that we are going to use is the cosine, since in the given we already have our adjacent and our hypotenuse, which is the B and C. Cosine theta is equal to adjacent over hypotenuse. Cosine A is equal to the B over C, where B is our adjacent and C is our hypotenuse. Cosine A is equal to 17 divided by 23, since our B is 17 and our C is the 23. Cosine A, after we divide 17 divided by 23, cosine A is now equals to 0.7391. So how are we going to find the value of angle A? Yes, very good. By using our scientific calculator. Remember what we had earlier? Yes. Okay, solve for the cosine A is equals to 0.7391. So what is our angle A? It is now equals to, very good, it is now equals to 42.34 degrees. Okay, how did we get 42.34 degrees? By using our calculator, we are going to click the shift sign and then the cosine. Enter 0.7391 and that will equate to 42.34 degrees. Okay, very good. You do know how are you going to use our scientific calculators. Okay. So now we are going to find the measure of angle B. Since we already have the angle A, which is equals to 42.34 degrees, and there is also one angle that is already given in the problem. So what is it? Can you take a guess? Yes, very good. The angle C. Since angle C is right angled, so therefore angle C measures 90 degrees. Very good. So therefore, in order to find our angle B, we just have to subtract angle C to angle A. Since our angle C is equals to 90 degrees, and our angle A is equals to 42.34 degrees, and then we are going to subtract the two. Angle B is equals to 90 degrees minus 42.34 degrees. And now our angle B is equals to 47.66 degrees. Okay, very good. We can also prove that angle A and angle B, at angle A is 42.34 degrees and angle B is 47.66 degrees. If we are going to add the angle C, the angle B, and angle A, this has to result to 180 degrees since the interior angle of the triangle is 180 degrees. Okay, did you understand, class? Okay, very good. And lastly, we are going to solve for A. Do you have any idea how are we going to solve for A? Yes. Actually, since we already determined the value of the C and B, we can now apply the Pythagorean theorem, which is equals to the A squared plus B squared is equals to C squared, right? Can you still remember that? Okay, very good. A squared plus B squared equals C squared. So what is already given? Yes, our A, our B, our B and C. So by substituting it to the equation, it will now become A squared plus 17 squared plus 23 squared. So A squared plus 289 from 17 times 17 is equals to 89 is equals to 529 from 23 times 23. And then A squared is equals to 529 minus 289 since we transpose 289 to the right side because 529 and 289 are like terms. So we are going to combine them together. So A squared is equals to 240. Since we still have the squared in A, we are going to take the square root of the 240. So A is equals to the square root of 240, then therefore the value of A is equals to 15.49. Okay? Did you understand, class? Yes, very good. And lastly, solving a right triangle given the length of the two legs. Example, triangle ACB is right angled at C. If A is equals to 118.5 cm and B is equals to 14.2 cm, find C, angle A, and angle B. First, we are going to illustrate it. We're going to draw it, or we're going to sketch it to have a better picture of the problem. It is said that triangle ACB is right angle at C. If A is equals to 18.5 centimeter and B is equals 14.2 centimeter, find C, angle A, and angle B. So here is the figure. Okay. So first we are going to solve for C. So we are going to solve for letter C, or the hypotenuse side. I will call. Yes, Shami, do you volunteer? Okay. Okay, thank you, Sami. Let us check if your answer is correct. Finding for C, we will use the Pythagorean theorem. Well, Sami is correct. Since A and B sides are already given in the problem, we can actually apply the Pythagorean theorem. So A squared plus B squared equals C squared. 18.5 squared plus 14.2 squared is equals to C squared. We are going to times 18.5 times 18.5 and 14.2 multiplied to 14.2. It is now equals to 342.25 plus 201.64 is equals to the C squared. And now, C squared is equals to 543.89. And since we still have the squared in C, we are going to take the square root of 543.89. The square root of 543.89 is 23.32. So therefore, the value of C, or our hypotenuse side, is equal to 23.32 centimeter. Okay, Sami is correct. So give Sami a clap. And for angle A, who wants to answer? Yes, Sylvia. Solve for the angle A. Okay, thank you, Sylvia. To find angle A, since A and B are opposite and adjacent side of angle A respectively, then we are going to use the tangent function. Our tangent function is opposite over adjacent. Tangent A is equals to A, which is the opposite, and B is our adjacent. Tangent A is equals to 18.5 divided by 14.2. Dividing 18.5 to 18.5 by 14.2, then it is equals to 1.3028. With the use of our calculator, the shift tan 1.3028 is equals to 52. So therefore, our angle A is equals to 52 degrees. Very good. Very good, Sylvia. Let's give Sylvia a clap. Lastly, how are we going to solve for angle B? Yes, Dominic. Thank you, Dominic. Is Dominic's answer correct? Yes, Dominic's answer is right. The angle B is equals to 38 degrees. Since angle C, which is 90 degrees, and angle A, which is 52 degrees, by subtracting 90 degrees to 52 degrees, we can obtain 38 degrees. So Dominic's answer is correct. Okay, very good. Okay, very good. Do you have any questions or clarifications with regards to how are we going to illustrate the 6 trigonometric ratios? Do you have any questions or queries? None? Okay, very good. So happy that you have understand our topic for today. Okay, so moving on, how the 6 trigonometric ratios generate ideas and understanding in the field. Trigonometric ratios play a vital role in various fields, from construction to navigation and to the arts. So, how are we going to apply the trigonometric ratios in our real life situations? Okay, first is in architecture and construction. Engineers and architects use trigonometry to calculate angles and distances, ensuring structural stability in buildings, bridges, and other constructions. So, if you observe in the buildings in our architectures, our buildings, There is a trigonometry, or the trigonometric ratios are applied to it in order to achieve stability, and that in order for our buildings not to collapse, because with one miscalculation it will ruin the whole process. And probably with miscalculation, our buildings, our architecture, the construction will collapse, and it will have a great damage to the property. So another is the navigation. In navigation, trigonometry is essential for determining the position of ships, planes, and satellites. Using angles and distances, trigonometric functions help calculate trajectories, headings, and distances between points. And lastly, in art and design. Artists and designers use trigonometry to create aesthetically pleasing compositions. It helps in understanding proportions, angles, and perspectives in drawings, animations, and designs. Right? Because if we can observe, there are many lines that are very essential in arts and design. So, trigonometric ratios are being applied there. Okay? Do you have any questions or clarifications? None? Okay, so question. What are the six trigonometric ratios? Um, Let me hear from Jake. Yes, Jake. What are the six trigonometric ratios? Okay, very good. So, Rajan, what is the ratio of the sine? Okay, very good. Precious, what is the ratio of the cosine? Okay, very good. Ashley, what is the ratio of tangent? Okay, very good. Rosemary, what about cotangent? Okay. Danica, what about secant? And Adrian, what about cosecant? Okay, very good. Lastly, Reynald, what is the reciprocal of the cosecant theta? Okay, very good. You have paid your attention very well to our discussion for today. So, do you have any questions or clarifications? None? Okay, please prepare one of sheet of paper and for our formative practice. Use your calculator to find the value of the following, correct to two decimal places. So answer here the 5 items, and I will give you 3 minutes to answer these. Hear me now, start answering. 2 minutes left, 1 minute left, 30 seconds left, 5, 4, 3, 2, 1. Okay, time is up. Let us now check your answers. Okay, very good. Almost all of you got a perfect score. Okay, so now we have another activity, an individual activity for you to further practice your skills in solving trigonometric ratios. On a clean paper, answer the following items. Sketch a figure and solve each right triangle ABC with right angle at C, given with these 8 items. I will give you 5 minutes to answer. Okay? You may now start answering. 4 minutes left. 3 minutes left. 2 minutes left. 1 minute left. 5, 4, 3, 2, 1. Time is up, class. Let us now check your activity. Okay, very good. 98% of you got the correct answer. And of course, we still have an activity for you. We have here an individual activity again. It is a reflective activity. Okay, on a clean paper, I think one hole. Okay, one hole. On a clean paper, create one scenario involving the 6 trigonometric ratios. Also include the reasons of the application of the 6 ratios in the scenario. Here is the rubrics for you for your guidance. We have here the content, 10 points, the organization of the ideas, 10 points, and the illustration, 5 points for the total of 25 points. I will give you 5 minutes to answer. Okay, I'm gonna start answering. 3 minutes left. 1 minute left. 5, 4, 3, 2, 1. Okay, class, time is up. Anna, please collect the papers of your classmates and give it to me. Okay, thank you. Class, do you have any questions or clarifications? None? Okay, none. And lastly, for our formative assessment, please get 1/4 sheet of paper and number your papers 1 to 10. Just write the letter of the correct answer. Okay? Number 10. Okay, now let us check your activity. Count the correct numbers of the paper that you are checking and please return it to the owner. Okay. Anna, can we collect the papers of your classmates again? Okay, thank you so much. So class, how did you find our topic for today? Yes, 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 for you it is very interesting. So what about you? Jonard, how did you feel about our discussion for today? Okay, I'm glad that you have learned from our discussion today. Okay, class, in order for you to have a deeper understanding with our top discussion for today, here is your assignment. Please answer this in a 1/2 sheet of paper, okay? And I will be collecting this in our next meeting. Are you all settled now, guys? Please pick up the trashes or the pieces of paper on the floor and arrange your chairs. Okay, goodbye class. Thank you and see you in the next meeting.